Let me introduce you to my Warco drill press. But could it be improved? Okay, so as a quick recap, let's just bring you up to speed of where we're at on this project. So the idea is we're converting this drill press into a variable speed drill press. It'll also have a table that we can move up and down on linear rails, so it should be more of a precision drill press. So we'll replace this table with an XY table that runs on linear rails with ball screws, and it'll also have DRO readouts so we can do some precision drilling. If we look at the top of the drill press, you can see all the head's been removed, so that's all been stripped down because the idea is, and at the top end here you can see that the head's been removed. We're in the process of converting that to run, instead of from the single phase motor at the back, it'll have the 3-phase motor on top just via a single belt with a couple of pulleys on there, and that'll drive the quill. And then to drive that 3-phase motor, we've got an inverter in the control box over there. So here's the control box so far. Obviously we've got it mounted to the wall, but the big thing you can see in there, that's the inverter, that runs the 3-phase motor. We've got the power coming in at the bottom. So the power comes in here via these distribution blocks that runs the inverter. This is the PTC, the temperature control system for the motor, so if it gets too hot that cuts out. And we've got a line filter there to stop some of the harmonics from the motor going back into the mains. And then right in the corner there we've got a 12-volt power supply. Runs off mains, and that gives the 12 volts supply to the logic system that runs the safety relay there. This relay here is an auxiliary one that runs the fan here inside the cabinet, and it will run the fan on the back of the motor. There'll be a cable from that control box up there which will go into here, and this will be the main control panel. So this will be our on off, forward reverse, and jogging very slowly if we want to cut threads. And then we'll have our speed control there. And right at the bottom, emergency stop. So this will go right on the front of the drill press. That's kind of as far as we've got. So the original motor, this is the single phase motor that was on the drill press, hung out the back. So you had the main head unit here, and then there was a plate here, and it hung off that. Well, it came through there anyway. We're not going to put the motor there, we're going to put the motor here on top of the main unit. So take that off, crop this off, you don't need that anymore. And I'm going to put this 3-phase unit on instead. But of course, because we're going to do that, we need to redesign the way that motor is going to be mounted. So let's look at that now. So in the last video you saw me skim this flat. So this is now flat and perpendicular to the spindle axis here. And the main motor plate will go on here. So there's a 6mm plate goes on, and it's bolted on at these M5 holes here. And then there are sides that come up, and the motor sits somewhere up here. Now because this is all rough cast, there's no real datums to pick up off to draw this in CAD, because I need to get this quite accurate so that the plate's actually going to fit. It's got to fit around this gap here, it's got to pick up off these holes. So I've taken the best measurements I can, and then I took the measurements between the holes and the distances here, so at least those were relatively correct, because that's actually more important. And then I made up this paper template, cut it out 1-to-1, marked the holes. And then I've just been checking just to make sure that these will line up correctly before I cut them out of the aluminium plate. And they're pretty close. But I did notice that these ones at the front here were about maybe 1mm out, so I adjusted that in CAD, and then that's what the new part should look like. So it should fit on there quite nicely. And it's a fairly tight fit around here, but I don't want too many gaps, because this is also keeping the kind of dust that you get off the belt from getting out here and going outside the machine and making it look all dirty. Right, so that looks pretty good. So let's go and see the plate we're going to cut this out of. Okay, so this is the aluminium plate that arrived the other day. So that will be the piece for the main, it's a 6mm, this will be for the main motor plate. So we'll get that out of there. Pretty pleased with that, it's pretty flat. It's obviously been guillotine, but it's pretty flat, or flat enough for what we need. and just enough material for that. This one over here, this will be later in the build. I think this is a 5000 grade, I think it's 5083, I can't quite remember, but that will be fine. It's still machines nicely. And this is 20mm. This is for another part of the build, but I thought if I was putting the order in, I'll get a few bits. And then these 3 bits here, these will form the 2 sides. So there'll be 2, a side like that, one on the other side, and then the third one will be a piece at the back there to kind of join them all together. You probably saw that on the CAD a few minutes ago. These are the 6000 grade, and now normally I would buy EcoCast or mill plate or tool plate. Basically it's been milled extremely flat, because the problem with this is you take your chances a little bit on whether it's bent or not, and sometimes that doesn't matter. It depends on what you're doing, but in this occasion I wanted them to be very flat. But in the current situation I couldn't get any the EcoCast from the usual places. I tried a couple of different places, I couldn't get it, so all I could get is some eBay stuff, and this is just general 6000 series T6 aluminium, and unfortunately, so it's clearly been, I guess it's been guillotined, but it's extremely bowed. That's probably one of the worst ones. Very cupped, as you can see. And they're all bowed to some extent. Now the 20mm plate, that's fine, and the 6mm plate very slightly bowed, but nothing really. But these are, so I'm just wondering what to do. I might be able to straighten them in the press. So I've just got it resting on these 2 blocks here, as far out as I can get it. That's, I don't think this is going to work, is it? Alright, that's basically me hanging off the handle. No, I can't even pull it straight, yet alone go past straight, so that, because we need to overbend it so it comes back flat. So answer is no. I'll probably just email them and just say they've arrived bowed, what can they do? So while we think about those, we can get on mounting this to the machine. I've done the cam for it, so we'll get that strapped down and get that cut out and all the holes drilled. Okay, so I've got the blank laid out there and the pattern on top, so we're easily going to get that out of there. So spoil board, I'm just going to use this chipboard here, it's just about the right size. So we've got that clamped down. So what we're going to do is just, first of all, we'll spot out each of the holes, and I'll drill those out, and then I'll screw through those holes to hold this plate down onto the board, and that will give that some security. And then I can machine the pockets right up to the edge, and I can machine the profile without having to move clamps and so on. And then in terms of holding the spoil board down, I've learnt my lesson long ago. You have to be really careful with this method because this is a little bit slippery. You need to really clamp it down well and give yourself some extra insurance. So I've got 4 of these clamped and they're pressed hard against the edge here, so it makes it very difficult for the board to slide underneath these clamps, so for a bit of added insurance. And before we start, I'll just show you the drawing. So there's not all the dimensions needed to machine this, but it's quite a lot of them in terms of the holes, because I don't want to make any mistakes. So I'll be piloting all these out with a 3mm drill bit, and then I'll take these out to size just with a cordless drill. That's the easiest way I've found to do it. You can't run, with this high-speed spindle, you can't run a 7 or 6.5mm twist drill in there, it just hasn't got the torque. So I'll just open these up to size, and what I like to do is, because there's a range of sizes, so what have we got here? So we've got 5.5 through hole, or 7, 6.5, and we need to tap 4.2 for the M5 fixings over here. As I like to draw the holes that are similar size at the similar angle, so the 7s all go out horizontally, the 5.5s come across at a bit of an angle like that, the 6.5 horizontal, and the M5s at another different angle there, just to try and keep them visually separate, because I don't want to make any mistakes. Alright, so let's start by drilling out the holes, and then we'll screw it down, we'll rough out this pocket, then machine it to final size, and then we'll do this bore, and then we'll cut around the profile. Here I'm peck drilling with a 3mm twist drill. So I haven't gone all the way through because what I find is, well, I find this method is a little bit more reliable. If you try and peck drill all the way through, every now and again you get a bit of chip weld on there and then that ruins the whole thing. You snap the drill, get stuck in there. And then I can finish them off with the cordless drill. And some of the holes are opened out to their final size. And then finally, some coach screws. I find these work really well. It was about now I realised I hadn't put a screw in the middle of that part, and luckily got away with it. So I've left 0.5mm on the wall. Here we are cleaning most of that up, just leaving 0.1. And I'm taking off the last 0.1mm just to give a nice clean finish. Now it's not critical, it's only a clearance hole, but makes it look nice. So these plates, I emailed the supplier and just said, oh, they'd arrived cupped and bent, was there anything they could do? And they said because there are stresses in the material, when they guillotine them, it releases the stresses and they bend and there's nothing they can do about it. And they said most people order something slightly thicker and then machine it down to size, which I guess could be true, but I'm pretty sure if you were just to bandsaw these, they wouldn't cup like that. I think the act of guillotining slightly puts that bend on them. Anyway, that's what they're saying, so nothing further offered. Okay, plan B. So while the plate's bolted down, I may as well put the M5 tapped holes in at the top. So they need piloting out to 4.2mm. Then a countersink. This stops the burr being raised to the surface when you put the tap in. And then I'm using this tap guide, this M5 little tap guide I turned up on the lathe some time ago, just to help keep it square. There we go, 2 M5 tapped holes. I've just got that one screw in there. You'll notice originally I'd called for a 19mm hole there in the centre, and I've not bored that out. I'm going to do something a little bit different with that. You'll see a bit later. And there it is. Now I've left the film on the other side to keep the protection on there, so we'll take that off. Yeah, it's a bit sharp. Deburr all the edges, and then we'll countersink the holes on the other side as well. I'll bring you back when that's done. Now for the really important bit, does it actually fit? Looks like it's lined up here. I think earlier in the video I said M5, these are actually M6. That's pretty good. Right, the rear too. Looks like they're going to fit. That looks really good. Very pleased with it. Looks great. Okay, so the next bits are... So these will be the sides, so they're still bowed, but I got a plan on that. I think I can do something with those. They basically, they'll screw up from underneath through here. So you one that side, and then one the other side, and then the third one will be across there in between, and it will be cut to about this sort of height. So I'll have the three sides there, and then the motor will sit up here, and we'll bolt in from the edges. Right, so that's looking great. And then this other fixing, a few minutes ago I said, well, I was going to bolt that out to 19mm and put a really big screw in here. But what I think I'm going to do instead, just leave this, I might open it out a little bit, but just leave it relatively small. And I think what we'll do, I'll just take this off. We'll turn an insert that goes into the casting, press it in with a shoulder, hold it with some Loctite, and then So I think what I'll do, I'll turn something that's a press fit in here with a shoulder on the back, so try and press it in from the back and put a thread in it, and then just screw down into that with just another M6. I think that would be a bit easier than trying to find, because if I tap this, there's a good chance it might crack the casting. I'm not really too sure, so I think a light press fit, Loctite it in, drill and tap. Let's just measure the bore. Try in a few places because it might not be round. Yeah, looks like it's 13.99. It's about 14 mil. .01. Okay, so it's about 14. Let's just try one more. Halfway between 13.99 and 14. Okay, so we'll machine something up with a shoulder. It's a light press fit in there. Right, something a bit like that. So it's just a piece of steel with a slight shoulder on it, and it's a nice press fit into there. But just to make sure it's not going to go anywhere, because obviously if this starts spinning in here, I won't be able to get the bolt out. But I think this will be pretty tight. So this is 638, so that should hold that in pretty tight, together with the slight press fit. So let's hope I got the length right. It doesn't want to stick through too far. Okay. So I turned the first part of that ever so slightly smaller so it would get it started, and now it should get tight. Feels like it's going to be pretty good. Right, let's see where that's got to. Yeah, okay, that's great. Just very slightly under flush. I did not want it to be over flush. Not go any more. No. Excellent. Okay, so we'll put the plate back on. Put a mark through there and we can drill and tap that. Okay, well, just taken these round to a friend who's got a big press. I think it's about a 50-ton press, and he tried to bend them, and basically what he said is the tonnage just kept going up and up and up, and they would go flat, but he couldn't really make any impression. We bought it in the end because I think this 6000 grade is not really meant for bending, and what might happen is rather than bending it over centre and getting it flat again, it might just start to crack. So I think we've got plan C. Okay, so at the moment that hole's quite small, it's like a 5mm I think, because then I can put the guide down and mark it through, and then I'll open it out to the 6.5 that we need. I'm just going to use this 5mm twist drill just to mark it. I don't want to use a transfer punch and hit it with a hammer, just in case it presses it back out again. So we'll just make a witness mark with this. Without dropping the swarf inside. There you go. Alright, let's see how it fits. Okay, we're back onto these side plates, and as you know, they are still cupped and bent. So our plan is, on the side pieces I'm going to machine pretty deep pockets to leave a web. I think it's 2mm thick just in the centre of the part, so there'll be a pocket in here and a pocket on this side, and it'll just leave a perimeter structure which will retain most of the strength, and because I've got the web in the centre, it will maintain the strength in torsion because that's where the stress lines will go, which will help. But in terms of bending, hopefully I'll be able to bend it flat. So let's get these machined. We've got the two sides and the rear to do. They've got pocket arrangements in each one. Cue the music. Finished all the machining for the motor mount brackets. So you can see in the end I machined a pocket here and on the other side as well. So there's a 2mm web left in the centre there. That was to help flatten this out so there was less material but maintain most of the perimeter, so we've got most of the strength there. These holes are slotted holes to allow for the motor adjustment. Some of these are to join the whole thing together, you'll see that in a moment. And then we've got our threaded holes at the bottom which hold it onto the main motor plate. So we've got two of those are the two side pieces. And then the piece goes across the back. It's a similar idea, machined a piece out there, so we've got a 2mm web. It's got our drilled and tapped holes in each end, and that will join it together like that. And then also over here, so these are just 4 simple spacers just turned up on the lathe, 8mm hole in the centre. So these are to space off the motor because it's got fins that stick out. You'll see that in a moment when we try and put it together. So there's 4 of those go around the outside and hold the motor in place. And then there's a kind of strengthening tube that goes across the front. So this is just a 20mm bar turned down the lathe, tapped M8 at both ends, and it kind of goes between the side plates just to give it some rigidity. The other thing I've managed to do is get these on the hydraulic press again. That was my friend's hydraulic press, and you can see they're not perfect but they're pretty close now. I think close enough for what we need for motor mounting brackets. You can see across there, looking pretty good now. So I think before they were pretty cupped, so they look okay. So they're all pretty straight now. So the next thing to do is just see if it all fits together. Okay, so we've got it turned round the other way now, so let's see if these plates fit. So these go on, just go on there. And they've got these M6. These are button head screws. I can get it in. Okay, that's the first one. Just leave those loose for now, and then we'll do. Actually, let's put this back piece in. It's probably better. Goes in there, and we've got these M5 button head screws to hold those on. And then we've got the other side that goes in here. Similar idea, we've got these button head M6 to hold it in. Okay, that's got it. And little M5 button heads at the side. Before we get everything too tight, and then there's one more fixing just under here. So I used the base as a template because it had a hole in it already, just to bore a hole all the way through, and then there's a thread tapped in the base of that. So that comes up under there, holds that in there. And we'll leave it all slightly loose. And then I've got this bar that goes in at the front with the M8 tapped holes. So this fits across the front, hopefully. Okay, so I've just tightened the other side. I couldn't really film that because it's a bit hidden around there. So the sides are done, so we'll just tighten up this bar front here. So you might be getting a bit more of an idea about how it's all going to look when it's finished. So the last thing to put in will be these 4 spacers. So these will go here. So there'll be an M8 bolt will go through there, or screw will go through there. So there'll be 4 of these spacers like that. And they go into the bosses on the motor that's down here. So it will be picked up on the lower 2 of the bosses on each side. So there'll be one like that, one there, and then 2 on the underside there. And then the side plates come up and finish about here, and the slots are sort of there. So I won't be picking up off the top ones, just the bottom pair like that, and then this will be the vertical direction, and then the slots will allow the motor to move fore aft to adjust the belt tension in the usual way. Alright, so pretty pleased with it so far, looking really good. Okay, so that's it for this video. Pretty pleased how it's gone really. This main motor plate's gone well. Got the side plates machined out, rear one as well. Got this spacer bar turned on the lathe, that works nicely, and these 4 little spacers that will hold the motor in here, allow us to slide it backwards and forwards. Okay, so we've still got to make a motor cover plate that goes over here. That'll be in a future video. And the pulley will go back on there, thread that on. That's it. Yeah, it's looking really good. So I think in the next video what we'll do, we'll get this up on the drill press, so we'll get it actually mounted on the column, and then build this up, because I think it's going to be a bit heavy to try and lift this and the motor into place. So we'll build it up in pieces on there, and then we need to have a look at, wiring it in and getting the control box wired in as well, because that goes onto the front of the machine down here. So we'll need to get the control cable through into this control box, get this wired up, and then get this running the motor. So hopefully that will be in the next video. See you next time.